In this example, we're going to compute probabilities of binomial experiments using StatCrunch. So if you need to, take a moment to pause the video and read the full problem statement. And for the purpose of this video, I'm going to assume that parts A and B are straightforward to answer, that you can identify why this is a binomial experiment, and you can identify N and P in the setup of the problem. So we're moving on down to part C, which asks us to find and interpret the probability that exactly 15 flights are on time. I'm going to show you two ways to use StatCrunch, and the first of this really relies a little bit more heavily on the formula than the second way. But notice here from our text, this is section 6.2, we see the probability of obtaining X successes in N independent trials of a binomial experiment. So I'm going to give StatCrunch this formula given that I know my value of N and I know my value of P for this particular problem. So what I've done over here is I started by just opening up a new StatCrunch screen, and I typed in those values of X for my problem, which would be the values 0 through 24. Next, I'm going to go to Data, Compute, and Expression. And here I'm going to build an expression that is the same as the formula that we just saw from the text. That formula starts with this combination. For StatCrunch, this function is the COMB function, so I've just double-clicked that to add it to my space up here at the top. N was 24, and I'll move my arrow key over one space. X is in the column labeled var1. Okay, so next I'm going to multiply by P raised to the X, so I'll say times, and for me, P is 0.8 raised to the X, or remember that for me is in var1, that first column. And then I'm going to multiply by, just slide this over for a second, 1 minus P, which again in my case that would be 1 minus 0.8, or in other words 0.2, raised to the N minus X. Again for me, N was 24, so I'll write 24 minus X. Okay, so I'll put here 0.2 raised, and I have an expression in the exponent, so let's type that out here. That's going to be 24 minus X, which my X's are located in var1, column var1. So I'll select OK. I have that full expression the same way that I see it in the text, but in StatCrunch's own language, and then I'll compute. Let me move this out of the way. And what I'm looking at here in this column are those probabilities of an X number of successes. So going back to my problem where it asked the probability that exactly 15 flights are on time, I could look at this row that has X is 15, and I find this is the probability that exactly 15 flights are on time. For the next part of that problem, you're just asked to interpret this probability. So I would think of that in terms of 100 trials. So let's multiply this probability times 100. That means we're expecting about 2 flights to result in exactly 15 flights being on time, or 2 trials, I'm sorry. Now in part D, it says, what's the probability that fewer than 15 flights are on time? Well, this is where my method may get a little too cumbersome. So fewer than 15 flights would be 14 flights and 13 flights and 12 flights and so forth and so on. I'd have to add everything up in this list from 14 up to here where X is 0. So let's look at a different technique also using StatCrunch. So I'll start with stat, calculators, and binomial. This is a binomial experiment. We saw that in part A, verified that. So I select this one. Towards the bottom of the screen, I'm going to give StatCrunch my information for N and for P. So for me, that was N was 24 and P was 0.8. Just to confirm that this is the same thing that's going to happen that occurred in part C, let's set this up for what's the probability that exactly 15 flights are on time. So I do have these choices that appear at the bottom of the screen. I don't know if I can show you all of these here. Let me see if I can move it just a little bit more. So when I click on the inequality symbol is probably how it's going to show up at first. You notice there's some other symbols to choose from, and I want exactly 15 and then compute. And notice it will give me the same answer as doing that entire table that relied a little bit more heavily on the formula itself. The other nice thing is I also see this distribution, the actual binomial probability distribution, and I see where this falls, this exact probability falls within that distribution. So that's nice to have that visual there. Another thing that's nice about this particular way of computing binomial probabilities is it's easier to find probabilities like the one asked for in part D, the probability that fewer than 15 flights are on time. So fewer than 15, I want to select less than 15 and compute. And notice everything that's highlighted here in red corresponds to fewer than 15, and I can find that probability pretty quickly over here. I just grab up that number. Again, you're asked to interpret that probability, so multiply it by 100 to put it in context of 100 trials. For part E, we're asked to find the probability that at least 15 flights are on time. At least 15 means 15 or more. So I'm going to change that phrase, at least, into its mathematical interpretation, which is greater than or equal to 15. And then compute. I need 4 decimal places, and actually that's 7. Let me copy this and paste it here. That's 7. We'll round the 3 up to a 4, like so. That's another thing I like about StatCrunch is I can copy and paste my answers directly into the answer box. So again, we're asked to interpret this, so we'll multiply that by 100, and we're expecting about 99 trials here. Next, in part F, we're asked for a between probability. So this is another nice feature of StatCrunch, specifically using, let me come back over here, specifically using where it said stat. Stat and calculators and binomial. Okay, so let me bring that back up. All right, so I want to find between. So up here at the top is an option for between probabilities. So when I select that, now the expression at the bottom of the page is changed so that I can calculate these, and I want the probability between 13 and 15 flights inclusive. So include the 13 and the 15. And if I look at my inequalities here, it does include the 13 and the 15. So I'll click compute. I see just those are the ones highlighted. Notice the ones less than 13 are not, and the ones greater than 15 are not. So here is my probability, and I'm going to round that to 4 decimal places. So I'm keeping mine to round up. And then the last thing is to interpret that by multiplying by 100. So in 100 trials of this experiment, it's expected that about 4 will result in between 13 and 15 flights inclusive being on time.